Okay, thank you everyone for joining us today for the University of Texas Energy Symposium hosted by the Energy Institute. I'm Kerry Keene, Assistant Director and Research Scientist. And today, before I introduce our speaker for today, I'm going to highlight what's coming up in the next talk or two. So next week, we will have Ben Byboff and Alex Creeley from Commonwealth Fusion Systems. So if you ever want to learn about what's going on in the fusion space, this is the talk for you next week. And after that, March 1st, we'll have a special talk that is also going to be part of our UT Energy Week. This will be Bruce Niemeyer, who is Vice President at Chevron for Strategy and Sustainability. Today, it's my pleasure to have Sergio Castellanos, who is a relatively new assistant professor here at University of Texas at Austin in the Civil Architecture and Environmental Engineering Department. And so he's going to talk to us about exploring inequities in energy and transportation systems in the United States and Mexico. So just a little abstract here, what we're going to hear. It's going to emphasize the way in which equity in the way in which sustainable technologies are rolled out and how decision makers develop their urban infrastructure planning, and how this is critical to ensure movement towards a just and inclusive society in the context of our changing energy system. And we're going to get a little taste of the US and Mexico differences. And so this is right up Sergio's alley, of course. He leads here at UT Austin what he calls the RESET Lab, or Rapid, Equitable, and Sustainable Energy Transitions Lab. And they're analyzing decarbonization pathways for emerging economies using data-driven, sustainable transportation approaches and equitable clean tech adoption and deployment strategies. And he works with many different organizations, including the United Nations, working with organizations within Mexico, and he's getting a lot of attention for his work here. So he's a former researcher at UC Berkeley, so we're glad to have him here. He also has his PhD from MIT, so hitting all the energy universities here. So with that being said, I will now hand it over to Sergio and stop sharing my screen. I will let everyone know to enter questions at any time on the Q&A feature of Zoom, and I will interject with Sergio with your question as I can, and if also can hold them till the end if that works appropriately. So please submit a question at any time. And with that being said, Sergio, I now hand it over to you.
Thank you, Kerry. Appreciate that introduction. And just to double check, you can see my slides?
It looks good. Thank you.
Excellent. Thank you so much. Well, it's my pleasure to be here today and talk to you a little bit of the flavor of the type of research we do here at the RESET Lab. As Kerry was saying, I just arrived a year ago to Austin. And the topic of today is a discussion regarding inequities in energy and transportation systems, two very important systems as a whole in terms of be decarbonized, with brief examples both here in the US, but also in Mexico. Before I go on, I just want to briefly touch on who we are, or the RESET Lab. We are a multidisciplinary group. We use data science to support equitable energy transitions, and we deeply care about how the technology is going to be rolling out in the years to come. So society is a fundamental part of what we try to understand and its nexus with technology and the clean energy space. More focus, perhaps, we focus on 4 different categories. One of them is manufacturing and deployment. This is pertaining clean energy technologies, an example here in solar PV. Also, of course, the deployment of such technologies and how they impact different communities in a different way. So in this case, energy and environmental justice and energy justice as a whole is one of the big topics that we're passionate about. Similarly, energy systems as a whole, looking at the grid, we have developing grid models for here Texas, but also have working models for Mexico, for Honduras, have had discussions with other countries as well in Latin America, and we're always eager to collaborate with more people around the globe. And lastly, sustainable transportation, which again is a topic that coming into this topic mainly from the energy side of things and looking at the electrification side of things. So to begin this discussion today, I will be mainly bringing forward a couple of topics and themes on how different disparities have been perceived across different sectors, and some thoughts on achieving those equitable rollouts of such technologies. So in this case, one first example, I'll be briefly describing is the solar photovoltaics in the US. And then I'll switch gears to talk about sustainable transportation in the context of the Mexican situation. So many of you might be quite familiar with this downward trends of solar PV costs, which have been quite impressive. In fact, an order of magnitude cost decrease in a decade or so. And that has really set the tone for PV growth in the US, but also worldwide. So within these drivers, as you can see, there's a portion, which is yellow, in this case, the module, but a significant portion also is the non-module side of things, which is related to the balance of systems, which includes structural components and installation. Innovation as a whole has really played a key role in decreasing this cost, and examples abound on how these tend to materialize. For example, reduce structural components for the installation, but also accelerated assessments to develop tools and how to acquire customers in a more rapid way and make an estimated approximation of the total yield that you might have in your rooftop, such as the case of Project Sunroof by Google, where you can gauge the solar PV potential across many millions of roofs here in the US and now expanding to other countries. Perhaps you can recognize this image that shows the potential here at UT, just quite remarkable. And so just as these tools expanded, the cost decreased over time and the deployment soared here in the US, but again, globally, some questions started to raise. And probably most of you have seen this in the past in the news, this type of questioning, whether solar PV was just mainly benefiting the rich. After reading this type of questionings and analysis and worries by the sector as a whole, this spurred a deeper question, which was really the seed that led to this project that I'll talk to you about today. And so the research question behind this is how equitable has rooftop solar PV adoption been in the US? And also, can we understand and see if there are any signs of disparity in terms of PV adoption among ethnic groups and races? So in this case, our group, Professor Deborah Sunter-Tufts, and Professor Dan Kamen at Berkeley, myself, we started collecting and using data collected by Google Project Sunroof's data. So just in a nutshell, if you're not familiar with this type of information, they take millions of oblique images, which they calibrate against solar insolation, but also electricity models. And through their deep learning models, they identify and refine the potential of PV systems and how much of those can be installed or are installed already in rooftops across the US. So they quantify, detect, clean up, and at the end give the result of, there is or not installation, this is the maximum size, but also this is the potential that you might have in a given place. So taking that piece of information, we also try to understand the social demographics behind that of the people, the groups of people that have adopted solar PV. So there's some cleaning process, as all of you might be very familiar with when you have a large data set. In this case, try to establish some thresholds for determining what's clean and what's not clean data. And at the end of the day, we understand a bit more comparing with the American Community Survey Census data. So it's an estimate from 2010, 2014 that matches, the information from Google Project Sunroof at the time of this study. We then create some categories to understand a little bit more in depth, who is living where. And so to do that and try to simplify our analysis, we create two different categories, which is majority, 50% of the population that identify with the same race and ethnic group, and another group, which will be the strong majority, which is 75% or above of a given self-identified race ethnicity. Lastly, to account for the potential variations within census tracts, but also for understanding the variations in insulation that you would get over a broad geography, name it a state, and the policies that could be also implemented across a given state. So we try to normalize for that. And we account by implementing this couple of normalization steps, in which we do that on a census tract basis, but then again, all the census tracts within a given state. So we can normalize on a per state, again, to account for these variations in policy, but also in insulation across different states of the US. So what we find is that, and what you see in this graph on the x-axis, you see a median household income that spans from low to high. On the y-axis, on the upper part, you see the census tracts that have been evaluated as a function of household income, but also as a function of self-identified race and ethnicity and ethnic group. So here color-coded different groups. And what you see here is the normalized PV deployment compared to a no majority census group or race and ethnicity. So in this case, what we're seeing is typically the comparison point will be this line, which is there's a well mixed group of races and ethnic groups within those given census tracts. And so everything will be compared against that. When we bring the deployment of solar PV across all these buildings that have installed PV in the past, we see that typically white majority census tracts tend to have above that no majority line. So they tend to install more than a well-mixed census tract in this case. And that is true across all incomes. So digging deeper into this data, we find that the same, in contrast, actually, Hispanics tend to install less, as we see here in the negative value across all income values. And the same goes with the Black majority census tract, which is consistently and decreases significantly, actually up and reaching higher income brackets. Showing that bringing the Asian community, now there's an issue about having a low amount of census tracts, but you get a trend that cuts across. But in general, the key takeaway that we find in this first pass is that white communities tend to install 21% more than the no majority established baseline that we said as a comparison point. But perhaps the worrisome aspect of this that leads to questions to be further analyzed is that Hispanic communities and Black communities tend to install 30 and close to 70% less in comparison than the other groups. And so this is a quite striking aspect. And digging deeper into this, there's this sociological effect that it's important when we're talking about P deployment. Once you start installing, it's been demonstrated that your neighbors tend to look at it. They see, your system installed on the rooftop. They want to know more about it. They install and so forth, it propagates basically. And so having that initial seed is important. And so understanding that in the context of what we just learned and discussed, we show this image that shows the percentage of total census tracts analyzed on the x-axis, and then y-axis just categorical, showing different groups. The important thing to see here is the distinction between color-coded and just dashed patterns here. Basically, this region here for the Black communities is about 47 or close to 50% don't have any single installation whatsoever. When we compare that against other groups, say Hispanic, Asian, and White, they have about 25%, 17% or so that don't have a single PV installation. And so linking that to the seeding effect, that's quite important because, as mentioned, just by looking at this graph, we see that there's about twice as less installation when you see any in the Black communities at all whatsoever. The important thing is that the initial seeding that we see here, if we focus on that section of those who have installed, we see a correction. So once a seeding has happened, we see that there's more installations happening, at least for the Black community group. And so this is encouraging because the calls actually for attention to understand where those seeds have been implemented or planted, essentially. And then there's some signs that at least the first implementation of that leads to a spurt again of adoption, at least for some segments of the income in this group. However, when we compare, for example, other groups like Hispanics in this case that have similar amount of installations in terms of percentage, and also similar in terms of no installation whatsoever. And when we focus on the positive attribute of that, we don't see this uptake as we have seen in other groups as well. So there are many hypotheses as to why might that be happening. Interestingly enough, there's some exciting forthcoming work from my colleague, Professor Deborah Sunter, which she's exploring the seeding effect in a deeper way and finds through time series analysis that this is indeed an important aspect for different communities as well. She developed this in a couple other states in the northeastern part of the US. There are still more questions and answers, and the root causes are unknown to a degree, but also we suspect there are many, right? So we hypothesize, for example, that in part this could be done due to credit biases, which, as you can see here in this FICO scores distribution, might not only be varying this spread as a function of low to medium to high income, but could also be varying as a function of race and ethnic group. So my colleagues are also trying to understand network diffusion mechanisms and diversities in the companies and how those have played a role in the situation in which we have find ourselves now. But I think the key point that I want to draw from this study is that answering this question really necessitates a multidisciplinary approach that kind of brings together different partnerships and perspectives to the table. And of course, there are obvious challenges ahead that require further disciplines and involvement as well. Some colleagues at Berkeley have found that these disparities also exist at the grid distribution level. And that's where the hosting capacity for just available as a whole for upgrades is limited in general, and as quoted in here, and this disproportionately lower to a Black identified and disadvantaged census block groups. And so there's already a deeper sense of inequality within the grid that we operate in. This is an example of California, but of course, one can think that similar situations might be occurring elsewhere. And when it comes to other new incoming technology and associated infrastructure, like EV charging infrastructure, for example, we see a similar consistent trend of disparities in the early stages of the rollout. Here, some studies have shown that there is, again, a slow deployment of public charging infrastructure in lower income, but also in Black and Hispanic majority and census tracts as a whole. So this is both alarming and important to address because this technology not only serve as climate crisis mitigation vehicles, but also as grid resiliency tools, especially when we think about them either vehicles as storage or solar plus storage. I don't think I need to give much explanation here to my fellow Texan colleagues because we all live at the same time, different levels of exposure to these extreme weather events of last years that disrupted this resiliency. And so this really prompts us to reflect on the current layout and the characteristics of our grid, but also on the tools that we have to address these current challenges. So solar and storage could play a role in alleviating some of these effects we observed during Winter Storm Uri. But the truth is there are many structural needs that we need to address as we reformulate our approach to hardening, but also building our future infrastructure. Whether this is in electricity, water, transportation, housing, these are all interconnected systems. And part of the forthcoming summary work that we have been developing here in collaboration with FOSS Research Group, with Kerry Stephens at the Optic Lab, Professor Michael Weber, and both TEPRI and Pecan Street, is that we're taking a stock of the still evolving effects of Winter Storm Uri here in Texas, and how that is potentially one of more extreme weather events that will happen in the future, but that can also increase the energy insecurity of our, especially of our most vulnerable communities. So as an example, and just trying to link this with the discussion on the energy systems, we posit that a deeper rethinking of our grid assets could be one of the many approaches to provide equitable resilience in our communities. And this is exemplified here, as we see in the image on the left-hand side, just aggregated SOx exposure from coal plants, essentially. And on the right-hand side, some average energy burden of low-income households. In this case, they just follow some general vision patterns. And as we think deeply about how we want to reconstruct the grid and harden it into the future, then it leads us to think and strategize into how to roll out these technologies, but also decommission other that are currently harming our communities. At an even more local level, we talk about the need for these tools to deploy them equitably, the challenge that we have lived just last year, but also geographically from the whole Texas and wider Winter Storm Uri. Now bringing this to a local context, we're seeking now to understand the implications, both the technical, but also the social dimensions of deploying a large-scale project here in urban setting in the Austin, Texas area, actually. So what we're trying to do here is just leverage on the knowledge from community solar experts and the documented best practices to understand what type of opportunities, but also challenges and disadvantages might we find as we construct this type of community solar type of projects to add for resiliency, but also again to understand the impacts of and limitations of potential systemic unequal access to type of technologies and proper infrastructure that can render this resiliency in an equitable way as a whole. So there's some of the questions that we are currently trying to address, and this is a work again in collaboration with Brian Korgel, Javad Mohammadi, and Surya Santos. So I want to switch gears beyond the US and also beyond the energy sector, and I also want to emphasize the motivation to address at least these two topics. What you see here on the left is the sector. What you see here on the right-hand side, the outmost part, is the greenhouse gas emissions. And when you take a stock of where the emissions are coming from, it's about 73% would be from the energy sector worldwide. This is global emissions, by the way. The first part is electricity that we talked about, PV, the grid, inequalities in there. The other big sector in here is transportation. Right? And so being in Texas, of course, and coming from Mexico, the natural thing to take a look at is in the border, so Mexico. When we think about Mexico, we just think about the first thing that comes to our mind is Mexico City, right? And I think, we all think about colors and food and whatnot, but there's also a lot of pollution. Here in Mexico City, you can see, I think, for those of you who are from there, who have been there, you probably will see this picture and find it quite familiar. And this is due to, in big part, to traffic. It's also due to fires and whatnot, but traffic plays a huge role. And in fact, Mexico City is typically considered one of the most, if not the most congested city in the world. So understanding and trying to link this aspect of traffic, of air quality, of climate change and emissions as a whole, this brings us together into this work that we have developed in alliance with international organizations, with industry, government, academia. And in this case, what we use is data from our colleagues at Google that are keeping track of the traffic patterns through Waze, coupling that with a motor vehicle emissions model, where we couple those two things, we feed it in a minute resolution, essentially, to understand the implications of different urban policies based on the transportation sector and focus mostly on the electrification side of things. And that's what I was mentioning, that is this connection with the grid or the energy sector as a whole. So what you see here, when we couple this information, we can now visualize the potential to reduce emissions based on some parameterized driving cycles and this minute-based resolution data that we collect in across many cities, actually. And what you see here is a reduction on PM 2.5, color-coded, spatial resolve, accounting for a period of time. If this first scenario that we present as a policy option and analysis, if we were to electrify all the taxi cabs in Mexico City, we would see about a 3% PM 2.5 reduction as a whole. Now, if we were to electrify the public transportation sector, that would lead to a 25% reduction in PM 2.5 emissions. And we'll go a bit beyond and trying to think about, really incentivizing and allowing people that wish to have a private vehicle for whatever reason, and they have access to an electric vehicle, then PM 2.5 emissions would be close to a 50% reduction in general. So this allows us to understand and quantify the importance of transportation and mobility in addressing air quality issues. Now, I want to take you beyond Mexico City, because as surprising as it might be to some of you, there are other places that can be as polluted or even more polluted than Mexico City. This is where Mexicali comes into play. This is in Baja California, border with California, border with Calexico. And so in this case, there's some news that really highlight the importance of this challenge of air quality in the region. And by taking a look at the emissions inventory in the state, we see color-coded on the right-hand side that the red portion of it really addresses in many of the pollutants. So we posit that if we were to invest in electric mobility, we can improve access, physical access, to marginalized communities, but also economic mobility to these segments of the population, as well as addressing some social marginalization, historical issues that have permeated in the region and actually in the country as a whole. So more succinctly, the research question is what type of opportunities are there to improve air quality in the border, because the border doesn't really care about visa status or anything. Whatever happens in one side of the border will affect the other one and vice versa. And again, this evaluation of the opportunities is in transportation sector looking at air quality. And so to ground ourselves in a common denominator, we adopt the EPA's environmental justice definition, which is fair treatment and involvement regardless of race, color, income. And this is in the participation for the drafting and implementation of laws, regulation, and policies related to the environment. So what we do is we take inspiration from CalEnviroScreen, which is a tool developed by the government in California, in which they rank basically their tracts from best to worst, being that associated with environmental exposure or burden. And so what you see here is color-coded in red. That would be like the highest score or the worst tract as a whole. And then the green would be the best or the lowest burden, environmental burden, that is. You should know that this is a tool that is used to disburse hundreds of millions of dollars of support and draft and push forward policies. Now, in this case, what we wanted to do is bring this down both at a city level, but also focuses only on transportation, not the entire breadth of different variables that are contemplated already in the CalEnviroScreen, just focus on transportation and bring it to a city level. So what we do is we collect data of different sensors situated across the city, and these are they're not low-cost sensors, but they're sensors calibrated by the governments. And this is for PM 2.5, PM 10, ozone. What you see here on the left is the monitoring stations. On the right is the interpolated interpolated dispersion of these pollutants. We're following the methodology from CalEnviroScreen, which aggregates over multiple periods of times, both within a year, but over multiple years as well. And at the end, we also, through our partnership with Waze, we can understand a bit more the traffic patterns and congestions across the city, which is yet another variable for our for the description of pollution as a whole. So I have pollution for transportation, and we have population. So those are the two variables that we mix together to create an environmental justice index in transportation and at the city level. So in terms of population, we have variables for asthma, for indigenous languages, which is a proxy for discrimination, limited mobility, population that is vulnerable, that is below 6 and above 65 years old, total population as a whole, and then marginalized population index, which this accounts for access to electricity, public sanitation services, running water, and so on and so forth. So at the end of the day, we combine these pollution and population indices to create a final aggregated environmental justice index that the city can use now to build on top afterwards. I should make a quick parenthesis and tell that we have developed a similar index for the greater Mexico City region, where there's 20 million people living. And what we find in there, when we're trying to evaluate the rollout of EV charging stations, there's actually a higher significant share of EV charging stations have been developed in regions of the city that are better in terms of environmental justice than those that have been in worse. So even though it's early stage, we have already used this tool to elucidate some of these disparities in Mexico City. Now, bringing it back to Mexicali, what we're trying to do is focus on the transportation sector, the public transportation sector. So we couple that environmental justice index, take a look at the public bus routes. We extract which are the most burdened bus routes, that is the ones that tend to cover more area, passing through burdened census tracts as a whole. From that, we can visualize which those are, which bus routes are those, and also understand what is the fraction of their commute that is crossing through some of this burden area. So what you see here on the x-axis is the environmental justice index score for the city on transportation, and the y-axis is the fraction of that bus route that covers that distance. We use those, that's our starting platform to understand and go deeper. It's the EJ index. So we take a look at the buses, we look at the top 10 that cover more burden areas. We take a look at demand and understanding also the public bus routes that tend to cover the most demand in the city. Furthermore, we apply some other criteria. So we look at where people are living and where are they working. So what you see here on the left is a residential map of the city or residential density. And you can start seeing some patterns of density here and density over here, and some also here in this northwestern and a little bit of spots in the center. Working, this also gives a little of intuition of where the economic units within the city are located. And this is just to give us a proxy for the exposure of the people that live and work near these places. So all to say that we combine this set of criteria, that is population, employees, where they live, where they work, the percentage of demand covered by the bus routes, but we always start from the environmental justice index principle to account for equitable decision-making in the process. So from this, we select or down select a set of 5 bus routes. And what we see here, however you slice or dice it, you see if it's by total population and gender or by vulnerable population within that gender as well, close to 50% of the city is being affected by these 5 bus routes. So this in a way is alarming, of course, but it's also a validation that you can make, starting from this environmental justice principles, you can already accommodate for a large portion of the population that need that support already. So a 50% of the population by these 5 routes that we take a look in deeper mode. Okay. So, brief examples of what do we mean by taking the next step after we construct the environmental justice index. So there's 2 ways that we talk about mobility. One is the one that we have ingrained in our minds, which is vehicles or buses. The other one is just walking, right? There's also biking, which we don't cover, but walking. So taking a look at walkability or the walking quality, we construct a walkability index for the city. And what you see here is the sub-selected bus routes in blue. You have a lighter shades of blue as well, which correspond to the 5-minute walking distance from the public transport spots. And those are the bus stops essentially, which are highlighted in yellow. So basically we have down selected bus routes selected on this criteria. We have their overlaying of each one of them within each of them actually. We have the bus stations, and when we have some coverage area of on a 5-minute walking distance. I should say that in this exercise, which was in collaboration with my colleague Rubén Garnica at Tec de Monterrey in Mexico, an evaluation of about 4,700 sidewalks and close to 550 miles of sidewalk were analyzed. And so we, just to give a bit more context, not to dive too deep into this, but our criteria for the walkability constitutes on normalizing distances within sidewalks, but taking a look at the obstacles that impede a nice walking through, and then a use of those sidewalks to go from one place to another, right? So in this case, positive is good, negative is bad. You can see here in red and green. And to show you some results, this is what the city looks like in terms of the walkability of it, which goes from bad, in this case, negative or yellow, to good, which is darker shades of green, which probably means nothing if you see it like that. So let's take a virtual walk. What we mean by proper walkability conditions, you see here in this case, you can probably see that there's wide sidewalks. It has enough space for people to transit. Clear signs on the upper image. So it's quite nice. And I think it's more evident once we compare the ones that have obstacles and we deem as improper. So there's some streets that have horizontal obstacles, as evidence here in this Google Street View images. You also see some vertical obstacles along the way. And perhaps there's no better way to highlight and emphasize the inequality that we observe in this aspect of the mobility dimension than this image, which shows, a vulnerable age population, women walking in close vicinity to that, one of the main bus stops or bus routes that we highlighted previously, but it's also walking in an inexisting sidewalk at all. So by this, we can highlight again these opportunities for urban leaders to take action into this and to encourage this alternative modes of transportation, which also impact our greenhouse gas emissions and also benefit air quality and health implications. Now, the second dimension in this discussion is the clean public transportation. So in this case, we partnered with a renowned company, Logios, to evaluate the feasibility of electrifying buses that can improve air quality in Mexicali. So in this case, basically, a couple buses, commercial bus models are modeled. In this process, we install some an app that was installed in a phone, which was then mounted on the buses. So we could collect driving cycles and just the characteristics of how these drivers were driving throughout the day, understand the patterns, acceleration, deceleration, their behaviors as a whole. And we, from those 5, we down selected to 4 bus routes, that the ones that I showed a couple of slides earlier. So to summarize the type of data that we collected, average speed, maximum standard deviation of speed, acceleration, deceleration, as well as idle time. So all this was captured on 1 hertz frequency. So every second we were capturing that data over and over again to, at the end of the day, construct driving cycles. So what you see here is a typical driving cycle, one out of many driving cycles that were constructed for each one of the bus routes. But you can visually start seeing that these tend to differ one from the other. And at the bottom line, what we're trying to do with this is construct an understanding of how the consumption of electricity might be if we were to transform those buses, which are currently diesel-based, to electric-based buses, right? And so here is a graphic showing, or 2 graphs actually, showing you information about this. On the upper graph is just a cumulative energy graph. So in black and blue is the baseline for traction. Passengers is in orange, and then as you turn the AC unit, of course, you would add more electricity consumption demand for your buses. Interestingly enough, here what you see, it's a pattern of how the buses are driving throughout the day. So you see 2 curves. One is blue and one is gray. Blue is associated with newly purchased bus, so fresh battery, if you will. And then gray is one that it's been close, or it's close to the end of its lifetime, right? So it just gives you that area distribution of the operational lifetime of the battery. You see here in the dash line, that's the state of charge under which you don't want to go through. It's like the critical threshold. On the y-axis, you see energy consumption, so it cycles. And it cycles, the green dots here denote that they have completed 1 circuit all throughout, and perhaps this is evident here. Well, I'll show you in the next slide. They have completed 1 circuit and they are able to charge back again. So they complete one circuit and they charge again and they go complete it and then do the same thing. So this is same spot where they begin, they end, and that's where they charge again. That's what this means. The red dots just highlight or denote the beginning of the day and the end of the day for this bus driving cycle as a whole. The important thing that you can see from this image is that, as in this route, specifically the first route that we analyzed, you see that there's a pattern. They charge, they go from the depot, and then they start the route. And so as they go, they discharge the battery, then they go up again. They barely make it without crossing this critical threshold, the state of charge, that there's some non-linearities, and then you degrade your battery faster. So at some point, they do go over that. And what this means is that at least through that charging scheme, this would be a difficult approach. Now, we evaluate other bus routes, and you can already get a sense of the length of these ones. But what it shows is basically that in this case, this bus route is never able to complete 1 cycle without having to stop and charge back again, right? The next one, it's a shorter bus route. It shows that even if it's fresh or by the end of its lifetime, it has the capacity to both charge and discharge continuously throughout the day, assuming it's at the same point there where it charges that starts and ends. And so it gives a little bit more flexibility to understand and perhaps visualize that this would be, in fact, a viable route to electrify, at least from the charging perspective. And lastly, there's the last bus route that we evaluated has this challenge as well, which might make it in the first years of the bus lifetime, or the battery lifetime, rather. But then it would get into trouble as the operations continue or the following months and years. And so at the end of the day, this is another way to represent, state of charge 100%, end of useful time, lifetime, and the critical threshold. But it just shows you that if you were to have a night charging, essentially, and you were to operate with that, basically it's almost non-feasible except for this one potentially and early on. So it just opens the question, it opens the door for more questions essentially. And that's, for the first insight, the result that we get from here, the most viable opportunity would be to charge would be to implement an opportunity charging scheme. And so that's basically where you have available equipment, both at the departure and arrival stops, versus this one that it's charging at the depot and then conducting your entire route over the course of the day. There is, of course, more room to optimize the charging strategies. So that's, room for potential further studies. And things that affect this, of course, it depends on the amount of people that you're carrying, the payload, how you drive. There's always the opportunity to educate drivers, instead of being so chopping their driving, like accelerating, decelerating. There's ways to optimize for that. The characteristics of the route. Maybe there's some actually active discussions whether it may make more sense to break those large routes into smaller ones to then think about potentially addressing these bus routes with electric buses. And so, and again, another policy that is being thought out, at least I don't think it's yet being at the stage of being contemplated. It's the dedicated lines only for electric buses. But again, in closing, and trying to bring these two topics into the table that I talked to you about, for PV, solar deployment, and also sustainable transportation, the US, Mexico, different things, but in both cases, we see that inequities can be found and should be addressed if we're trying to achieve sustainable energy transition. Tools that are data-driven can help us, but not solve, of course, the entire issue. They're useful to identify some of these inequities that and help us drive this collective thinking and start pondering how can we address them. And lastly, these are meant to be data-driven tools that can support urban policymakers, just stakeholders, so they can take meaningful climate action. And so with that, I'll leave the space to any questions that you might have. And as mentioned earlier on, rather new-ish here, 1 year at UT Austin, but I'm always eager and happy to engage with other faculty members here, students, both at UT Austin, but also beyond, talking cross-border works, and also, a huge appetite to go beyond Latin America. So happy to entertain any questions and connect with you all.
Thank you very much, Sergio. Okay, please, submit questions. I have maybe some couple general thoughts here or questions. One is you presented, I guess data is like lots of data-driven analyses and summarizing many of these in some kind of index, right? To get the environmental justice index, you have some other indices, walkability. In this type of work, is that just kind of where it tends to go to make it more easy to communicate with the policymakers or stakeholders on the ground, is to aggregate a bunch of data into an index that's a little abstract? Do they like that, or how do you think about presenting the data in terms of indices versus the actual numbers and things? Any insights there? Yeah, no. So I would say it's very situational. Interacting with different cities, some tend to appreciate this, and it makes her understand the situation holistic and better. I would say, as a whole, measuring inequities is quite an active topic of discussion. How do you measure that? At what stage? What do you contemplate? In fact, we're part of a working group that's trying to address that question and give recommendations, because I don't think it's an easy question. How do you go about that? Probably also one of the things that I can highlight, you probably noticed, this is just one flavor, and you mentioned it correctly. It's very data driven, but aspirationally, it would be, I would like to expand beyond and also look at the other, start from the ground and ask, from survey development, interacting with the community, and then building up that and highlighting that type of burdens. So this is perhaps looking at aggregated stuff, but it's important and something that I'm trying to push forward in some of my projects, to look at the other dimensions, start from the community up. So different flavors, active topic of discussion, and there is some appreciation for having things aggregated to easily make decisions that contemplate dimensions that otherwise wouldn't be contemplated at all. Right. And if they want the underlying graphs and data, I guess you can always show them that too. Exactly. There's one question that I was thinking when you presented. I don't know if it's more applicable for this place, a country like the United States versus Mexico, maybe both, but maybe I was thinking more along the lines of the U.S. and your discussion of EV and PV infrastructure or installations in different neighborhoods that have different racial makeups. I wonder if, do you ever hear an argument such as the following that someone might have to investing in the grid that, well, why would I invest to build up the grid infrastructure in an area, perhaps lower income, minority areas that don't have a lot of EVs or photovoltaics, to build it up, even though with the hope or the thought that they'll have PV or EV later, versus invest in areas that are maybe higher income or that already have PVs and EVs. If you understand my question, has this argument ever come up, or is this a thing you think in terms of just allocating money and investing in the grid, or how would we think about that problem?
Yeah, no, it has come in different ways, but some of the things that we find is, and it's known, for example, at least owning a car, that is a tool for social mobility. It has been demonstrated. I don't, there's a lot of debate about, whether that's the way we should all go as a society, or just eradicate that as a whole and just, do walking, biking, which means reconstructing our cities, which, there's also a positive argument to that. But just the whole, it's been known that if there's incentives to be aimed at having access to a private vehicle, that includes social mobility. And so if that's the case, and which, that's the path forward, then by all means, that should already be looking into the next direction of having electrified. Some arguments have been made, like why install in an EV charging station, for example, in a place that probably no one will drive. But there are associated benefits to that, of course, and we're thinking linking that to infrastructure. Most of the time you have to do upgrades in the distribution grid, for example, which would have to be done anyway, or perhaps not. And that's there's a thing. Perhaps it wouldn't have to be done. And by trying to bring this upgrade to the grid, then you're not only improving the conditions for grid stability, grid reliability at the local level, but you're also opening the opportunity to host EV charging stations. So just to say that perhaps it's more a systems-wide level type of investment, rather than just to say, if I don't put a vehicle EV charging station here, it won't have if I put it here, it won't have an impact in the transportation sector. I think it crosses across multiple sectors, and that's the thing that needs to be evaluated. Because those type of investments tend to impact, as you said, construction, the grid, transportation. Right. And so that's a little bit of how discussions have evolved in the place that I've been.
Right. So here's a question about your environmental justice index. The question is, does your environmental justice index that you were using, is it the same, or does it differ from what the Environmental Protection Agency uses as an environmental justice index? And maybe you can, if you're aware of that, or maybe you can remind us the components just to have a better context.
So, okay, this project, the one that I talked about, Mexicali, was sponsored actually by the EPA. So it follows their guidelines. The spirit was this to homogenize discussions between California and Mexico, and to try to make it as easy as possible. It differs in the sense that they have more than 20 variables for the description of environmental burden. In this case, and they have it for the entire state at a tract level. So in this case, we deferred by two ways. First, we brought it from the state to one city. So we want to make it like urban level. And then the second, we obviated many of the variables that are not transportation related. So an example would be proximity to wastewater, or that type of information that really doesn't connect directly to transportation. So we clean some of those variables out, and we focus on the city level, and that's how it differs. Other than that, whatever variable that we kept, it followed for the most part the same guidelines as the EPA, which is aggregating over 3 years and 8 hours increments, and then doing the interpolation the same way they do it, weighting equally. That's another thing, because you would say, what's more important, having vulnerable population or asthma records, or how do you weight each one of them? That's a tricky question, perhaps very philosophical. We talked to the developers of CalEnviroScreen, and it seems like that's what they do, just weigh equally. We went with that as well. So in that way, that's similar still.
Great, thanks. Along the lines of your, I think the Mexicali study, and looking at the air pollution, I guess the particulate matter and ozone type pollution. Do you have a feel for how much of that is related to less, I don't know, standard pollution control equipment like catalytic converters and things on cars versus just a lot of cars? Because you're talking about, here's the pollution, at least in the Mexico City example, reductions you could get from electrifying. But I guess I was wondering, is there a normal step that we have already taken in terms of mandating certain pollution controls on that the air quality would already be better, or is it just kind of the nature of the beast in those areas?
That's a good question. I don't have information which is more granular as to what specifically, what type of measures could be driving those pollution levels. That's a good question. I'm not sure.
Okay, sorry, just wondering.
No,
yeah,
that's a good one.
Yeah. Some places got bad geography, and the pollution's just bad there.
Yeah, and no, I mean, geography plays a role. There's also, habits. There's a lot of habits also, and they reported like burning tires, for example. In some of the fields nearby. That's also lack of pavement. Also, drive some of that PM as well. But yeah, I mean, those are variables that play a role. You don't see that same across all cities, but I know at least in the local context, those are significant. The exact percentage, I'm not quite sure, but yes, those tend to play a role.
Let me ask one final one here. It's maybe more generic question about, I don't know, urban planning or mobility, but that could still related to electricity related transportation. So you looked at, buses and showed us some examples of the bus routes. Is it kind of becoming a thing that people are tending towards, we'll just stay with buses instead of trying to figure out whether to invest in rail, or does it just not make sense for a lot of places in Mexico? I mean, here in Austin, right, they've been sort of voting on rail here for decades, and it's semi non-existent. There's one line, maybe some other ones coming. So it's always a challenge, but any general thoughts on sort of, let's just say, electric travel versus rail and electric travel versus buses, which are now an option, and they weren't really an option, 10 years ago.
Right. So there's perhaps two stories. One in Mexicali, there's of course a desire to implement like clean air related transportation or sustainable transportation as a whole. Not much resources, and so I don't think they're going to the extent of saying about rails and whatnot. However, in Mexico City, they have just a breadth of different modes of transportation, and they have in the past used electric-based trolebuses. They're connected to cables on the top. Those are, for the most part, fixed and given routes, so they don't have the flexibility of electric buses. However, there have been pilots recently launched in Mexico City. And so I think there is a shift, and there's a desire to continue expanding that option. I don't think it's as aggressive as it's needed, and I would posit actually that some authorities have hindered that or haven't been very enthusiastic. And so the appetite, if anything, has been driven by the industries and trying to launch their pilots and prove to the authorities rather than the authorities trying to bring them and trying to incentivize them. So it's that, if anything, that's what's driven the adoption of those pilots in Mexico City.
Right. Thank you. Okay, well, we'll end it right there. So thank you very much, Sergio Castellanos, assistant professor here at UT Austin in the Civil Architecture and Environmental Engineering Department. Thank you for joining us.
Thank you.
All right.